So my name's Andy Watts. I'm an architect with AWS here in Singapore. I'm part of the ProServe organization, and we're going to take the next 30 minutes to do a very gentle introduction to security on the cloud. So when we start our security conversations, we usually start with what we call the shared responsibility model. So security is really both of our jobs, us as the cloud provider and you as the customer. So as a cloud service provider, we're obviously running the data centers, so we're responsible for the facilities. All of our data centers are nondescript buildings. The locations are not advertised. There's no logos on the buildings. We don't do data center tours. In my 2 years at Amazon, I've actually not been to a data center here. But we have a lot of security around them. The perimeter is monitored. People going in and out are authorized and logged. And then we manage the physical infrastructure, the bare metal, the servers, the routers, the switches, the storage devices. We manage the virtualization layer. So for most customers, they'll be multi-tenanted with servers running, instances running on hardware that also hosts other customers. So it's important that we maintain the isolation there. And then we do hardware lifecycle management. And this is most important when it comes to storage devices. So anytime a storage device reaches end of life, and it's being moved out of our data center, we need to make sure that any data that was on that is irretrievable. So in the case of disks, what we do is we degauss them, we punch holes in them. In the case of SSDs, we have a very powerful shredder. Actually, a colleague of mine who had been to the data center, he made the mistake of taking his phone in, and given our security policies, his phone had to go through that same shredder on the way out. It was an expensive day trip. So that's AWS responsibilities. So the customer's responsibilities, well, in the case of instances like EC2 servers, the customer gets to choose the operating system, Windows, Linux, which versions they're running, and that's pretty much where the customer's responsibilities start. I mean, we have no visibility into what you're running. To us, it's pretty much just bits and blocks. So it's up to you to make sure that you're running a secure version, the patches are applied, that you're managing accounts on that operating system properly. Security groups, ACLs, firewalls, we give you a lot of tools to help you do this, and I'll go through a few today, but it's ultimately up to the customer to make sure that they're locking down their firewalls. So this is what this looks like. This is, again, for EC2. As you can see, Amazon is responsible for the foundations, the compute, the hardware, the storage, and then when you get to the customer layer, they're responsible for deciding whether to use encryption, the account management, the firewall configuration, application configuration. And this is pretty much what it looks like when you just come to us and say, I want a server. But as Blair mentioned previously, we have a lot of managed services, managed databases, managed NoSQL, managed streaming services, and this is how the responsibility is shared in those scenarios. In these scenarios, you're pretty much consuming the service via an API, and we're responsible for any operating system, any application configuration, and we take on a lot more of the security burden. In these scenarios, typically you'll be configuring whether you want security or encryption and the account management, but the lower level stuff is all done by us. So once we got past this shared security model, the next thing we usually talk about security is, do you know what's in your environment right now? And because if you don't know what's in your environment, it's very hard to know whether you're secure or not. And for a lot of customers, this is pretty much what it looks like. They're on-premise, and they've been racking machines for years, and it's very hard in a data center like this to know what's connected to where, what interfaces are running, what firewall rules are up and running. And so the beauty with AWS is that pretty much everything is software-defined. So using the console, you can get up to the minute access to all of your servers. You can see which IP addresses they have, which subnets they're in, what firewall rules are, what storage volumes are connected. You have a complete access to see what is running in your environment. And just being able to have that visibility really, really improves your ability to secure the environment. Okay, let's move on. So I'm going to go through a few services, and the first one I want to talk about is virtual private cloud. So when you sign up with an AWS account, probably the first thing you'll do is create your VPC. And what that means is you're going to tell us what your IP address range is going to be. And later on, you're going to cut this up into various subnets and add firewall rules. But at the very beginning, you're going to say, I want an IP address range, maybe 10.x or 192. And that's yours. That's logically isolated to you at layer 2. So every person in this room could have a network with the same IP address range, and you would never see each other's traffic. If some of the hackers here might decide to run Wireshark or TCP dump, it's all isolated at layer 2. So you would never see his traffic and vice versa. So here we've created our VPC, and in Singapore we have 2 availability zones. So each availability zone is an independent cluster of data centers, and they're connected by high bandwidth, low latency connections. And so we always encourage customers to deploy their applications in an active-active fashion spread across these 2 availability zones. So what I've done here is I've got my 2 availability zones, and I've created 2 subnets. When you create a subnet, you have the option to mark it as public or private. And if it's private, it's going to use your private IP addressing. If it's public, the instances that you deploy in that subnet are going to get public IP addresses. So here I've deployed 2 servers in each availability zone, both in public subnets. I've added an internet gateway. And so at this point, these machines have public IP addresses. They're open and live on the internet, probably being port scanned in a matter of minutes. And so we clearly need to add some security here. So customers are often very familiar with firewalls, and so the first question that comes up is, how can I add a firewall on AWS? Well, on AWS, a firewall, we call it a network access control list. And like a firewall, this works at the router or the gateway that connects 2 networks. So the internet connecting into your private network, there's probably a router there, and you're probably doing packet filtering there, firewall there. And that's what network access control lists do. So this red and black outline of the subnet indicates that with network access control lists, you can add firewall rules that will filter traffic into the subnet. But we try and go one better than that. We have something called security groups. And these are essentially firewalls at the host. And what the benefit of security groups and firewalls at the host is that they can help secure traffic within the subnet. If you're familiar with firewalls on the router or on the gateway, they're checking traffic as it flows into your network, but once it's in your network, the traffic isn't going to hit them. And so security groups running at the host, at the virtualization layer, are a far better place to have your firewall rules. And you configure these in the console, so they're transparent to your operating system. You can keep your Windows or your Linux machines fairly clean and simple. No messing with kernel modules. You just go into the console and you block everything. Maybe you're allowing port 80 for your website. You can give these security groups names. You can configure them so new instances are automatically added into a security group. And you can build up complex rules. You might say that servers in my web security group can access my database. And it's very easy to give them names and see what's going on and make it dynamic and make it easier to manage. Another difference here is that security groups are stateful, whereas network ACLs are stateless. So using network ACLs and security groups, we've blocked a whole lot of ports, but we've probably allowed HTTP through to our website. And a lot of attacks these days take place at layer 7 through the firewall onto the ports that you have open. And so last year we announced the AWS WAF, the Web Application Firewall. So this works to inspect your HTTP requests as they come into before they come into your server. It has a big library of rules, and so every request is inspected to make sure that it's not trying to do SQL injection or cross-site scripting or buffer overflows. So it works on our edge locations, on our CloudFront servers, and you can go into the console and you can pick and choose which rules you want to apply. You know your applications better than anyone, so you can add additional rules that apply, and then you can actively monitor and tune it. This is kind of what it looks like to manage. So you might have a security officer using the console who's managing which rules apply, but then you'll also have developers. They'll know what API paths are, what requests are valid, what parameters are valid, And so developers can also define the WAF rules using the API. Once they've submitted the rule set into the WAF, they're deployed into CloudFront on the edge. And so all requests before they come to your web servers are passing through the CloudFront edge location and being sanitized. So we're relatively new to the web application firewall business. And these companies here have been doing it for some time, Alert, Logic, Imperva, and Trend. And so what we've been able to do is integrate their rule sets into the WAF. So these guys are very good at detecting zero-day vulnerabilities, proactively pushing out new rule sets. A lot of companies are already using them, and so we integrate tightly with those. The next tool I'd like to mention is Trusted Advisor. So this has been around for a long time in AWS. It's a series of checks that we run against your AWS account, and we give you a report, which you can see here. And we check a number of things. We check if you're cost optimized. It's easy to move cloud providers, so we always want to make sure that you're not spending more than you need to. We check security. We also check fault tolerance, and we also check for performance. And so what you can see here is actually a scan I ran against my own account yesterday. And I'm a bit embarrassed to say that it found some of my security groups and some of my network access control lists were not as tight as they should be. And so it's given me a summary report here. And if we dive into one of those, this is one of those items we saw on the last slide where we're talking about unrestricted access. And you can see here from my own website, I have SSH port 22 from anywhere in the world. So it's highlighting that you still need my password or my key, but you can attempt to connect at least from anywhere in the world. And so it's suggesting that you lock your firewall rules down a bit further. The next service I want to mention is Amazon Inspector. So Trusted Advisor that I just showed you, it's all about your Amazon configuration. How are you using the tools in the console? Amazon Inspector is a small piece of software, an agent that you install on your machine, Windows or Linux, and it does some inspection of how you configured that machine. How are your users configured? What's your patch level like? How is your logging configured? And it gives you a very detailed report. And this is what it looks like. And so you can see here that it's running a number of different rule packages. So it's checking the authentication configuration, it's checking for common vulnerabilities, it's checking the patches, but it's also checking for PCI DSS compliant. So if anybody here is trying to build a service that you'll be taking credit card payments for, you're probably going to be looking to be PCI DSS compliant. And so running a tool like this, it's going to check your server configuration and tell you what enhancements you might need to make before you apply for that PCI certification. And we can drill down further. If we take the top item here, authentication best practices, and we drill down further, it gives us a further detailed report. And to give you an idea of what's going on here, it's found that we can log on to the server over SSH as the root user. And so the recommendation is to disable the root user and make people SSH using a non-privileged user. Okay, moving on. Amazon KMS, Key Management Service. So we launched this about 2 years ago, and the goal was to make encryption as easy as possible. If you've ever tried to encrypt your boot volume, you know how challenging it can be. You want to automate your things, but then your encrypted boot volume is stopping for you to provide a key or a password. And it's just stopped a lot of our customers from using encryption as widely as we would like. And so when we created this service, it was all about making it a one-click to get it enabled and making it automated and making it as easy to use as possible. So to give you an idea of how easy it is, I took a couple of screenshots. So this one on the left, I'm creating a storage volume. I'm creating a 100 gigabyte SSD-backed storage volume that I'm going to later attach to one of my servers. And you can see towards the bottom here, there's one checkbox, encrypt this volume. And on the next line, I get to choose my key. So when you sign up with AWS, everybody gets their first master key in KMS. You can then use that key to make subsequent keys. And so often we see customers create keys for individual services, or keys for production and non-prod, or keys for different business units. And so you'll end up with a whole series of keys. It's a key chain, a hierarchy of keys. And so here you'll just choose which key you want to use. And after you hit create and the volume is created and you attach it to your server, from that point forward, every time you read and write to that volume, the bits are going to be encrypted and decrypted. And it's completely transparent to the operating system. So again, we want to keep your operating system as simple and clean and as easy to manage as possible. But as your requests pass through that virtualization layer, it's going to be encrypted and decrypted. It doesn't get much easier. In this screenshot on the right here, this is from RDS, which Blair mentioned previously. RDS is the managed database service. So again, as you go through and you're creating your SQL Server, your Postgres, your MySQL database, you'll go through a multi-step wizard, and at one point it's going to ask you whether you want to enable encryption or not. So you simply select yes, choose the key you want to use, and again, from that point forward, every time you read and write to the database, the blocks are going to be encrypted. If that volume, that storage device, or that volume, or that snapshot, for any reason, was out in the wild, it would be useless because it would be encrypted. It's probably the easiest way to encrypt your data that I've seen. The next service I want to mention is CloudWatch logs. So another challenge with security is getting control of all of your logs so you can see what is going on in your environment. And we see customers struggle with this all the time. And so we created something called CloudWatch logs. And again, it's an agent that you install on your machine, and by default, it's going to push all of your logs from that machine, all of your system logs, so your var log messages, your syslog, from that machine into a central repository where you can then go into the console and view them. You can add your application logs as a simple text file, add as many logs as you want, and they'll all be pushed into this central repository. And then you can go to the console and you can inspect the logs from an individual server. You can see aggregated logs across all of your web servers. If you've ever tried to track down a request and you're not sure which web server it's gone to, you can see all of your logs aggregated from all of your web servers. You can say, show me everything from 9 o'clock to 9:05 across all my web servers this morning. You can aggregate across all of your devices. You can go back in time. It's a very simple way to get your logs under control. So when we talk to compliance and audit teams, one thing they always ask is that they want a good record of what has changed in the environment. They want to see who's changed what and when they did it, how they did it, where they did it from. And so we created something called AWS config. So if I were to go in and add encryption to a volume or start a server or resize a database, all of that information is logged. And using AWS config, I can go back and see what has happened to this server over the last year. Who stopped it? Who started it? When did they do it? Who changed the firewall rule? And I can also go back and say, what did my application look like at the beginning of the year? What servers was I running? How big were they? How much was it costing? And so AWS config for audit and compliance and visibility of how things have changed over the time is a really wonderful tool. Another tool we have is CloudTrail. So again, this is for the audit and compliance people. Every API call you make, and if you're using the console or the command line or the SDK, every change you make eventually calls our API. And so we're recording every single one of those requests. We're recording the IP address it came from, the user account that made it, any parameters that came with that request, and the response that went back to the requester. So we're logging everything. And by default, we put it in S3 for you, and you can keep that for as long as your audit requirements are. But for larger enterprises, they often want to put that into their enterprise software, something like Splunk. Identity and access management. So this is how you manage your users and your groups and your policies in the cloud. So, and there's another aspect to this I want to mention, which is roles. So if you've ever had to put a password into a configuration file for an application, you kind of know it's a security risk. You're probably not going to go back and change that password as often as you should. So with IAM, we have this concept of roles. And what roles allow you to do is to say this server or this application has rights to access this S3 storage bucket or this database or this cache. And when that server or that application starts up, it's going to get a piece of credentials, a short-lived credential that it can use. And that just stops you having to hard-code passwords into application configurations. Another aspect with IAM is that it integrates very well with SAML 2 and Active Directory. So when we talk to larger customers and they're adopting the cloud, one of the questions they ask is, am I going to have to create another user account for everybody? Is everyone going to have to learn a new password? Am I going to have to create new user groups? And in most cases, they have all of that on-premise in an Active Directory. They have leavers, joiners, movers, processes. They have groups with restrictions around what those groups can do. And they've built that up in Active Directory over years. And so what they can do is they can federate Active Directory into AWS, into IAM, and achieve single sign-on and just maintain that control in the same place they always have. So normally at this point, we show a slide with about 150 certifications and compliance accreditations, and it's quite overwhelming. So today I tried to highlight just two of the more useful ones. PCI DSS compliance. For customers who are building e-commerce sites and they're taking credit card payments, you're going to need PCI DSS compliance. And what that involves is completing a questionnaire, detailing all the controls you have in your environment. And it's a lengthy, difficult process. When you use AWS, most of our services are already PCI DSS compliant. So you can ask for our report, we'll send it to you, and it contains our controls and the language that we use to get our services certified. So Blair previously mentioned RDS, our Managed Relational Database. That is, in the case of MySQL at least, it's PCI DSS compliant. So if you were to build your e-commerce site using RDS, you could get our controls, and when you're completing your questionnaire and your submission, you can copy the language from our report, and you're that much closer to becoming compliant. The other accreditation I want to mention is the Singapore MTCS, multi-tier cloud security standard. So this is a 3-tier standard from the IDA in Singapore to certify cloud providers, and AWS was the first global cloud services provider to achieve the highest level of certification, level 3. So we've talked a lot about the AWS platforms and tools, and this is all about giving you the tools you need to fulfill your responsibility and secure your operating systems in your environment in AWS. But what I also want to mention is that the customer ecosystem is a huge asset. So we have customers like GE and NASA, Pinterest, Dropbox, and these customers are always pushing us to make our security better. And anytime we roll out a new feature or a new service and we work with these enterprise customers, we roll it out to everyone. When we're rolling out these features in New York, it's either immediately available or shortly thereafter available in Singapore. And then the partner ecosystem. So we have an AWS Marketplace. It's very much like an app store for your phone. It's somewhere you can go and get enterprise software like Trend Micro, BMC, Alert Logic. You can get machine images of this software pre-configured. It gives you a guidance of which EC2 instance to use. And so you can take this software for a test drive. And in many cases, they charge by the hour or charge by the day. So you no longer have to do a huge investment to see if this software is correct for you. There's some resources I want to share with you before we finish. This is our homepage for security, aws.amazon.com/security. On this page, we link to all of our white papers. We have white papers on risk, security, and compliance, white papers on achieving different accreditations, PCI DSS, HIPAA. We have white papers on integrating with Active Directory. And then we also have links to a whole series of videos and trainings that are online. On training, we have our self-paced labs. You can go online at any time, sign up for these self-paced labs, get some hands-on experience, go through some tutorials on how to configure things like security groups, the NACLs, multi-tier architectures. We have instructor-led training here in Singapore. We have our instructor booth outside. And then we have certifications if you want to validate your experience and boost your job prospects. So to wrap up, I want to leave you with this quote. This is Todd Soderstrom, the CTO of NASA Jet Propulsion Laboratory. You know, NASA know a thing or two about security. And a couple of years ago, Todd very kindly said this: based in our experience, I believe we can be even more secure in the AWS cloud than in our own data centers.